I'm here excited to bring programming language for children known as Scratch. So Scratch is a programming language that is known as a high-level block-based visual programming language and a website for primarily at children, aimed for primarily at children as an educational tool. So if I click here, we have got what is called Scratch. So it is going to load. I'll give it time to load. Scratch is loading. And then a small history of Scratch. So Scratch 3.0 is the current version that we are using. So this version was released in 2019. That is around approximately 6 to 7 years ago. And this edition has been very stable, 3.0. The predecessors of this coding, it first appeared in 11th October 2003. That is 21 years ago. So the version by then, it was 0.1. And then in May 15th, 2007, they released a version called 1.0. In May 2013, they released another version called 2.0. So May 17th, 2007, that was 1.0. May 9th, 2013, 2.0. And then 2nd January 2019, they released the current version, which we are going to use. It's called 3.0. It's a very stable. It has been there for long. And they have just modified it. Now we have got offline version, which was released on 27th February 2022. Yeah, that was around 2 years ago. Offline, whereby you can do your programming without relying on the internet. It is offline. So the interface for this, I've just given you as a narrative. The interface is like this. It's categorized into three. The first area is called the block palette, where you use your visual blocks to prepare the programs, the codes. And then this is the code area. This is the stage. And then this is the sprite panel, whereby you can add other sprites. But the default sprite is called the cat. So we have got the block panel, code area, and stage. Let me see if it has opened. Let me maximize it. So this is how it looks, the user interface. It has got three main sections. The stage area, this is the stage area. And then we have got the block area. And then we have got the script. The script will be arranged on this area here. So this cat by default is the one that we use. And I just want to introduce you to the block. We have got different code blocks. We have got motion. If I click on motion, I'm in motion. If I click on looks, I'll get looks blocks. If I click on sound, it will give me the sound blocks. If I click on events, to give me that. So all these are 9. But you can add more using the add extension so that you have more visual blocks to use. So I've prepared a small PowerPoint that we can just do the basic, very, very basic of it. So if I come to this PowerPoint, I project it. In Scratch, this is a very fundamental cardinal points for movement, for motion. If you are pointing towards north, you are moving, gravitating towards north, we refer to you are going 0 degrees. If you're gravitating towards the east, you are moving towards 90 degrees. Yeah, so this is a quarter turn. A complete turn is 360. So if you move from north to east, you have done a quarter turn. If you gravitate towards south, that is 180 degrees. That one you'll have done a half turn. So that is 180. And then if you gravitate towards west, negative 90, and then back to complete the 360. So this negative 90 is west, 90 degrees is east, north is 0 degrees, and south is 180 degrees. So this is the cardinal point for motion. And you can see on the scratch, the first block was motion. So this is very fundamental for somebody to put in mind, especially young ones who are learning programming. So this programming language is targeted to ages 8 to 16. 8 to 16. So it helps them be able to think out of the box and be able to be creative. The next thing here is a project, a small project. A sprite, which can be the cat, it can be the pencil, follows the path shown on the diagram below. To move from point A all the way to point B, so it will move from here. So when it is here, it will point towards east. So when it is pointing towards east, that is 90 degrees. You're gravitating towards 90 degrees. So after you have pointed the direction, you have to point the direction, then you move 50 steps. So by doing that, you'll be in this corner here. For it to move down up to this corner here, you have to gravitate towards south, which is 180 degrees. So you'll point 180 degrees, and then you move 100 steps to enable you be here. So for you to move from this corner here, yeah, to this corner here, you are going to point again east, which is 90 degrees. And then after pointing 90 degrees, you'll move 100 steps. While you're here, to go to your final lap to reach B, you'll be pointing up. And up is 0 degrees, that is north. So you will point 0 degrees and move 50 degrees. So you want to use this diagram to create a small program for motion, just for introduction. And then later we can come up with complex, like now, for example, if I go to the next one, this one will be pointing even, you can see that it will point negative 90 here. Here it will point 180. Here it will point 90 degrees and then 180. So 180 is here and 180 is here. And going this side is negative 90. So back to the first screen. So if I open Scratch and I'm about to do this, so it means that I have to position the cat on the western side so that I draw it moving towards the eastern side. So what I'll do first, I don't want to use the cat. I want to use another sprite called pencil. So to delete this grass and do away with it, I'll come and click here. It has gone, and then this will enable me to choose a sprite. So the sprite I want to use, all these can be used as sprite. So the one I want to use is called pencil. So pencil is here. So pencil has already appeared visually. So the size is so huge, so I can reduce the size. I think 50 can be ideal. And then I position it somewhere here using coordinates of X and Y. So if I position it, the coordinates move, they keep on changing, depending on if it is horizontally. If it is on the X axis, it will change on the X axis. This is X axis, and then we have got the Y axis. So the Y, if you're going down, the Y changes significantly. And if you're moving it towards the X axis, it also changes significantly, if you check here. Now, I'll position the pencil. I want it to start from here, this corner. I'm just trying to imagine that I'm starting from this side. So when I'm starting from A, I have to point towards east, which is 90 degrees. But in Scratch, you have to start with events, the yellow one. So you can decide when the pencil, the sprite is clicked on, when the flag is clicked. So I can take this one. Let me zoom a little bit so that you can see clearly. So when the sprite is clicked, now because I'm using the pencil and I don't have any pen here, I'll need to add another block, the 10th one, called pencil. So I'll go to add extension, then I take pen. So I've added one called pen. So now in total there are 10. 1, 2, 3, 4, 6, 7, 8, 9, 10. There are 10. So what I'll do, I'll start by using the pen now. I'll start by saying erase anything that can be on the stage. And then after that, I have to set my pen color, the color that I'm going to use. So I can click here. If I want black, I'll play with this thing until I get black. Now that is black. So that is black. The pen I'm going to use is going to be black. And then I have to sharpen my pen. It has to be well pointed. 3 is a good for the pen to draw nicely. And then of course, I have to tell that before I put the pen down, I have to take these coordinates that I've used here so that it will start from here. But I cannot do it before I put the pen down. So I'll have to come here, look for the coordinates. The coordinates is negative 70 on the x-axis, and the y-axis is, I can't see it clearly, 85 or 65. So I'll take this one, this block, I drag it to the script area. How comes it's not moving? So it has moved. There it is, it's negative 70. And then I go back to pen, is when I put the pen down. I was putting pen down so that when it moves there, it does not draw a line when it's moving there. So I've already set the whatever, the pen. All the pen parameters are well set. And where I'm going to start drawing is also set. I think that is okay. Now I need to go back and see how I need to move now. So if I go to PowerPoint, I'm supposed to move from here to here. So that is 50 steps, but I should point 90 towards east. So I'll come here, and then I now go to motion, then point direction. So pointing direction, when it is pointing this side is 90. When it is pointing this side is 0 degrees, that is north. When it's pointing west is negative 90. When it's pointing south is 180. So you can see the concept. So I should point east. After pointing east, I was supposed to move 50 steps. I was supposed to move 50 steps. Because if I check this thing, I'm supposed to move 50 steps. Now I'm in this corner. I should point south, which is 180, and then I move 100 steps. 100 steps. So I'll come here, and then I'm supposed to move south. So if I click south, now that is south, and then I'm supposed to move how many steps? 100 steps. So these are step-by-step instructions I'm giving the computer in Scratch language. Now, let me see where I am. I'm in this corner now here. Still, I need to go towards east and move 100 steps. So if I'm moving towards east, I'll point 90 degrees, and then I move 100 steps because I'm just trying to navigate towards the direction I'm shown here. Now I'm here. So the last step, I should go towards north, and north, going towards north, we agreed it's 0 degrees. Then I move 50 steps. So when I come here, I'll point in direction, point in direction. So first of all, you have to point and then you move. So I'll tell it I'm moving towards north, which is 0 degrees. And then I move how many steps? I'll have to confirm. Just 1 minute. I need to move 50 steps. So I'll move 50 steps. So let me see if my codings are going to be 1 minute. Just to check. Sorry for that. Let me see. I was just checking if my scripts are step by step. So if I click on the flag, because we said here we can click the flag. So if I click on the flag, I've managed to draw what was supposed to be the movement. That is the movement. So if we look again, we just check this script. Let me reduce it a bit. If you look at the steps, is that when the flag is clicked, erase all, set pen color to black, set pen size to 3, and then the reason why I put this one here was to start from a specific place. To start from a specific place. So the coordinates was negative, x is negative 70, y is 65, so that it starts from that particular place. Even if I erase it like this, and then I put the pen here, it will start from here, not there, because I've already specified the coordinates. So if I click here now, can you see that? But the problem now, it has drawn a line which was not supposed to be there. That line was we have supposed to put pen up to avoid this kind of line that it has drawn when the pen was somewhere there. So I'll go to pen, then I say pen up. So I put pen up before the coordinates. So let me again erase, I disconnect the script, then I put the pen somewhere. Let's say I put it here, and then I come and put here. So if I click here, it will start from there without drawing the line. I'm repeating again. Pen up is when the pen is up, it will move to a specific place and then the pen is placed down for it to be able to draw. If you don't put pen up here, it will draw before it's to the coordinates and then start drawing. So even if I disconnect it again and take the pen somewhere down here and then erase all. So if this pen up is not there, it will move to the coordinates that I've said here by drawing a line to that coordinate. That's why I'm saying pen up. So if I click here, it will draw it without drawing the line as it goes to the specified coordinates. So the point that I want you to get is point in direction and then move. 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 And then you get your diagram. And in my PowerPoint presentation here, these are the coordinates that you use. If you're pointing towards north, 0 degrees, east, 90 degrees, south, 180, west, negative 90 degrees. So that is a very, very basic concept of using Scratch. Later, we are going to do complex projects. I don't know if I have any that can be shown, but for example, if I was to draw a triangle has got 3 sides. A triangle has got 3 sides. So let me be able to throw all these away. And then also this one, I can change this one. I want it to start at 0. Let's say 0 coordinates. When I say 0 coordinates in the middle. So if I go to the calculator here, and then I say calculator, I want to do some calculations. A triangle has got 3 sides. So a complete turn is 360. So I want to see the exterior angle of a triangle. So I'll divide it by the 3 sides. So if I divide 360 by 3, I'll get what? 120. So 120 will be my turn. So let me erase all here. I'm trying to draw a triangle. So what I'll do, I'll come here and go to a place called motion. So under motion, I'll say, let's say the measurements on the sides of the triangle can be, let's say 100. So I'll say move 100 steps and then turn according to the calculation we did. What did we get? 120. I think it was 120. Yeah, if you divide it by 3. So the turn here will be 120. Yeah, so you move the sides of the triangle will be 100, 100, 100, but the turn is going to be 120. You take 3 sides of a triangle, divide by 360 to get 120. And then, because of the 3 sides, I'll go to a place called control and say repeat how many times? 3 times. So if I connect here and then I click on the flag, I have a triangle. But this triangle of mine is somehow tilted because the direction here, let me put the direction here to be 90 degrees. So let me see. So you can see now it is a triangle. So this concept of looping, I'll be able to create more videos on the same so that we can create complex diagrams using these visual blocks that are on Scratch 3.0, and this is an offline version which is very, very stable. This offline version is very stable and it has been there for quite a number of years. This Scratch is very good for students, young ones, because it engages their brain. So expect more videos that will be able to engage the young ones. And with that, I'd say thank you so much.